Section 1.4, Solving Other Types of Equations. In previous sections, we have solved linear equations and quadratic equations. So we're going to kind of do a little bit of all of that in this section. So example 1 asks us to find the real solutions of the equation shown below by factoring. So I have 3x to the fourth minus 27x squared equals 0. Remember, when I'm factoring, the first thing I always want to try is pulling out a greatest common factor. Here I see that the greatest common factor is 3x squared. Both terms have 3x squared in them. When I factor that out, I'm left with x squared minus 9, and I have equals 0. Then I look at the quantity that's in the parentheses and see if I can factor it further. Hopefully you're starting to recognize that this x squared minus 9 is a difference of squares. So I can factor that a little bit further. 3x squared. Now this x squared minus 9 is going to factor to x minus 3. Let me get my mouse. X minus 3 times x plus 3. And we still have it equal to 0. Now I have three factors. I have this 3x squared, I have x minus 3, and I have x plus 3. I have them all factored, and now I can use the zero product property to set each one equal to 0 to find my solutions. So 3x squared could equal 0, x minus 3 could equal 0, and x plus 3 could equal 0. And I solve each of those. The first one, I'm going to divide both sides by 3, which is going to give me x squared is equal to 0. To get rid of the square, I take the square root of both sides. So that leaves me with x is equal to 0. The middle one, I'm going to add 3 to both sides, which gives me x equals 3. And over here, I'm going to subtract 3 from both sides, and that's going to give me x equals negative 3. So my three solutions to this equation are 0, 3, and negative 3. Example 2. Solve x divided by 2x plus 1 is equal to 3x plus 2 divided by 4x plus 3. I need to get a common denominator. So when I look at this, I'm going to go ahead and put 2x plus 1 and lump them together because they're stuck together, and then 4x plus 3. So my least common denominator is going to be 2x plus 1 times 4x plus 3. Now, let me rewrite what I started with. Let me get the black pen. So I'm going to write it in parentheses, I had x on top and 2x plus 1 on the bottom. Over here I had 3x plus 2 on top in the numerator, and 4x plus 3 on the bottom in the denominator. Now I can show you how to get that least common denominator. What is missing over here on the left-hand side from our denominator? Well, 4x plus 3. So I'm going to go ahead and put that in the denominator. If I put it in the denominator, I also have to put it in the numerator so that I'm not changing the value of this fraction. On the right-hand side, I'm missing the 2x plus 1. So I'm going to put that in the numerator and the denominator. Alright, I could cancel out the 2x plus 1 divided by 2x plus 1. That's equal to 1. Okay, but that would put me back to where I started. Now, once I have a common denominator, I can go ahead and ignore the denominators. I know that if the denominators are equal, that the numerators are going to be equal. So that leaves me with x times 4x plus 3 is equal to 3x plus 2 times 2x plus 1. At this point, I need to figure out how to solve this. So what I'm going to do is I'm going to distribute the left-hand side and distribute on the right-hand side, which we'll call foiling. That's going to leave me with 4x squared plus 3x equals, when I FOIL on this side, 3x times 2x is going to give me the 6x squared. The outer, 3x times 1 is going to give me plus 3x. Inner, 2 times 2x is going to give me plus 4x. And last, the 2 times the 1 is going to give me plus 2. All right? So I have 4x squared plus 3x is equal to 6x squared. I'm going to go ahead and combine the 3x and the 4x to give me 7x. Now, I have all of these terms. In order to continue to solve this, I can tell it's a quadratic. I have these x squared terms. I want to get everything on one side. To do that, I think it's easiest to go ahead and move this 4x squared and 3x to the other side. Why? Well, I always like to have my x squared term to be positive. Okay? So by subtracting 4x squared from both sides, that's going to give me a positive x squared term on the right-hand side. So now I'm left with 0 on the left-hand side equals 6x squared minus 4x squared is 2x squared. 7x minus 3x is a positive 4x. And then we have plus 2. So now I'm going to go ahead to a new screen so that we can go ahead and continue factoring this. Now that I'm on a new screen and I have some more space, we're looking to factor 2x squared plus 4x plus 2 equals 0. Remember, when we're factoring, the first thing you always want to look for is a greatest common factor. These three terms all have a 2 as their greatest common factor. When I factor that out, I'm left with x squared plus 2x plus 1. All right? So now I say, okay, I have this 2 out here, which is a constant. I don't like dealing with constants, so I'm going to divide both sides by 2 to get rid of it. So over here, the 2's cancel out. That leaves me with x squared plus 2x plus 1 is equal to 0 divided by 2 is 0. Now I have a quadratic on the left-hand side. I've taken out the greatest common factor. Now I want to factor using the AC method that I taught you guys before. So take a minute. If you need to pause the video, please do, and find the factors of x squared plus 2x plus 1. The factors come out to x plus 1 and another x plus 1. Now that we have it factored and we have it equal to 0, we can use the zero product property. The zero product property, remember, tells us that we can take each factor and set it equal to 0. Well, notice both of the factors are the same. So we don't have to solve this twice. We can ignore one of them. When I solve this, x is equal to -1. Now I need to make sure I go back and make sure that it's okay, that it works. So my original equation was x divided by 2x plus 1 is equal to 3x plus 2 divided by 4x plus 3. So you would plug this -1 into the top and to the bottom of both sides and make sure it comes out equal. The other thing you're really focusing on looking for is making sure that this value does not make the denominator 0. If it doesn't make the denominator 0, you should be good to go. So put -1 into the denominator here. 2 times -1 is -2. -2 plus 1 gives you -1. This side is good to go. Over here, put -1 in. You also get -1. Good to go. Okay, so again, you're checking in the denominator to make sure that it doesn't equal 0 when you plug it back in, because that would give us an undefined fraction. Example 3. Solve x divided by x minus 2 plus 2 divided by x plus 3 is equal to -10 divided by x squared plus x minus 6. Just like the last problem, we have to find our least common denominator. Alright, here the denominator is x minus 2. Then we have an x plus 3. And over here, I want to go ahead and take a minute and factor that to see what this denominator looks like. So, if you take a minute and go ahead and pause this, you're going to get x minus 2 times x plus 3 when you factor this denominator. Alright, and we can see that we have some common factors. Our least common denominator in this example is going to be x minus 2 times x plus 3. So just like the last example, what I'm going to do is I need to figure out what's missing in each fraction and put that in the denominator and the numerator. So let me change my pen again. So just to show you what we originally had, we had in this first fraction x in the numerator, x minus 2 in the denominator. In the second fraction, we have 2 in the numerator, x plus 3 in the denominator, equals, I'm going to go ahead and put this negative with the 10 so we don't lose it on accident. And in the denominator, I'm going to put the negative 10 in parentheses, I have x minus 2 and x plus 3. So I just rewrote the original problem with a little extra spacing. Let me go back to my white chalk. Now, what is missing in this first denominator? The x plus 3. Remember, if I put it in the denominator, I have to also put it in the numerator. In the second fraction, I'm missing the x minus 2. And in this fraction here on the right-hand side, I have both components of the least common denominator already. So like I told you guys before, once you have everything with that common denominator, you can ignore them. We know that if the denominators are all the same, that the numerators are going to be equal to each other. So we have x times x plus 3 plus 2 times x minus 2 is equal to negative 10. Now, you may have gotten up to this point doing different steps, and that's okay. There are different ways to do that. The key is to make sure that you get the same equation that I have once I have this distributed out. So I'm going to go ahead and distribute. X times x plus 3 gives me x squared plus 3x. 2 times x minus 2 is going to give me 2x minus 4. And then I have that equal to negative 10. I'm going to go ahead and move the negative 10 to the left-hand side by adding it. And I'm going to combine like terms. So I have x squared. The 3x and the 2x is going to give me 5x. So plus 5x. Minus 4, and then again I'm adding this 10 to both sides. So I'm going to do plus 10. Is going to give me a positive 6. And on the right-hand side, I have 0. So I have x squared plus 5x plus 6 equals 0. I have a quadratic, and now I have to work on factoring it. I'm going to go to a new page so I have a little bit more room. At this point, I would pause and make sure that you can factor x squared plus 5x plus 6 on your own without me walking you through it. But I'm going to go ahead and put the factors down. The factors of this quadratic are x plus 2 and x plus 3. I now can use the zero product property. So x plus 2 has to equal 0, or x plus 3 has to equal 0. That leaves me with x is equal to negative 2, or x is equal to negative 3. Now, I have to remember to check my answer. So remember, what you're looking for is to see if when you plug one of these values back in, if it makes the denominator 0 and makes it undefined. So when I plug negative 2 over here, negative 2 minus 2 is negative 4. That's okay. Negative 2 plus 3, that's okay. And when I plug in negative 3 into here, that's okay. I'm sorry, negative 2 into there, that's okay. The problem arises with this negative 3. When I plug negative 3 in here for x, I'm going to get 0 in the denominator, which means it's undefined. So negative 3 is not a solution. The only solution to this particular problem is x equals negative 2. This section again is about solving other types of equations. So the next type of equation we're going to look at is a radical equation. And here are the steps for solving radical equations. Step 1 is to isolate the radical. Step 2, you're going to square or cube both sides and simplify depending on the type of problem. Step 3, you're going to solve the resulting equation. And the very last step is you're going to check your answers to make sure you don't have any extraneous solutions. Example 4, solve the cube root of 2x plus 3 is equal to 3. So go back and look at your steps. Remember, the first step is to isolate the radical. We have a radical on one side of the equation with nothing else on the outside, okay? We have this cube root all by itself. So we're good to go. Step 1 is done. Step 2 says to either square or cube both sides and simplify. Well, since we're doing cube root, we're going to cube both sides. All right, when you cube a cube root, they undo each other. So we're left with 2x plus 3 on the left-hand side. And on the right-hand side, 3 cubed is going to give you 27. Now we're down to solving a basic linear equation. I'm going to subtract 3 from both sides. So I have 2x is equal to 24. I'm going to divide both sides by 2, and that's going to give me x is equal to 12. Remember to check your solution, so let's plug 12 back in. Okay, here's my check. Cube root of 2 times 12 plus 3, we want to see if that is in fact equal to 3. Well, 2 times 12 is 24. 24 plus 3 is 27. Is the cube root of 27 equal to 3? Yes. So my answer to this. Example 5. Solve x minus the square root of 6x plus 7 is equal to 0. Now, remember the steps say to first isolate the radical. Notice my radical is the square root of 6x plus 7. Well, it's on the same side as this x, so I need to have them on different sides of the equation. But since there's this minus in front of the radical, it's actually easiest to go ahead and add the square root of 6x plus 7 to both sides. I'm going to add the square root of 6x plus 7 to both sides. So I now have x is equal to 0 plus the square root of 6x plus 7 is just the square root of 6x plus 7. So again, step 1 is to isolate the radical. Once you've isolated the radical, step 2 is to either square or cube both sides of the equation. Well, since we're dealing with a square root, to get rid of a square root, we're actually going to square both sides. So on the left-hand side, I have x squared. On the right-hand side, remember the square and the square root undo each other. So equals 6x plus 7. Well, notice I have a quadratic. How do I solve a quadratic equation? Well, first I want to get it in the right form. So I want to move the 6x to the other side and the 7. So I have x squared minus 6x minus 7 is equal to 0. Now I have options, okay? I can try to factor, or I can use the quadratic formula. I prefer to factor if I can in any situation. So again, if you need to pause it, please do, and take your time getting the factors. The factors for this come out to x minus 7 and x plus 1 equals 0. Using the zero product property, I'm going to take each factor and set it equal to 0. That leaves me with x equals 7 and x equals negative 1. Then I have to go in and check. My last step is to check. So when I put 7 into the original equation, I get 7 minus the square root of 6 times 7 plus 7 should equal 0. Well, 7 minus 6 times 7 is 42. 42 plus 7 is 49. What is the square root of 49? Well, it's 7, so 7 minus 7 does equal 0. So x equals 7 is a solution. Now, let's plug in negative 1 and see what happens. Negative 1 minus the square root of 6 times negative 1 plus 7 should equal 0. Alright, 6 times negative 1 is negative 6. Negative 6 plus 7 is 1. So we have negative 1 minus the square root of 1 should equal 0. Negative 1 minus, we know the square root of 1 is 1. What's negative 1 minus 1? Not 0. So we have just one solution, x equals 7 to this equation. Example 6. Solve the square root of 3y plus 1 minus y is equal to negative 1. Remember, the first step is to isolate the radical. So on this example, I want to move the y to the other side. So I'm going to add y to both sides. That leaves me with the square root of 3y plus 1 is equal to negative 1 plus y. I'm going to write as y minus 1. Okay? The next step, once you have the radical isolated, is to get rid of the radical sign. In this case, it's a square root. So to get rid of a square root, we're going to square both sides. Now be careful. Make sure you're squaring the entire quantity y minus 1, not individually squaring these terms. On the left-hand side, the square and the square root undo each other. So we have 3y plus 1 equals, on the right-hand side, I'm going to write it out as y minus 1 times y minus 1. You can't just individually square the y and the 1. This is actually a foiling problem. Okay? So now we have 3y plus 1 equals, I'm going to FOIL out this right-hand side. That gives me y squared minus 1y minus another 1y, and then the negative 1 times the negative 1 is going to give me a plus 1. Simplify, I get 3y plus 1 is equal to y squared minus 2y plus 1. Alright, and now I can tell I'm going to have a quadratic that I need to get everything on one side so that I can either factor it or use the quadratic formula. So I'm going to subtract 3y from both sides, and I'm going to subtract 1 from both sides. Alright, get everything on the right hand side just because my y squared is already there. That leaves me with 0 equals y squared minus 5y. Alright, the positive 1 and negative 1 cancel out. How do I factor this? How do I factor y squared minus 5y? Well, remember, the first thing you're always looking for when you're factoring is a greatest common factor, which in this case happens to be y. When I factor out a y, I'm left with y minus 5. Once I have it factored, I can use the zero product property, set each factor equal to 0. So y equals 0 and y minus 5 equals 0. So y equals 0 and y equals 5. But remember to check. Remember to check. To check this one, I'm first going to use y equals 0. When I plug y equals 0 in, I get the square root of 3 times 0 is 0 plus 1 minus, I'm going to plug 0 in for y again, and that should equal negative 1. Well, what is 0 plus 1? 1. What is the square root of 1? 1. And what is 1 minus 0? Well, it's not equal to negative 1. So I can go ahead and eliminate y equals 0 as one of my solutions. Okay? Let me erase so I have a little bit more room over here. So I can check the y equals 5. When I plug in y equals 5, I get the square root of 15 plus 1, which is the square root of 16, minus 5, and I want to know if that's equal to negative 1. The square root of 16 is 4. 4 minus 5 is indeed equal to negative 1. So my solution is y equals 5. Example 7. Solve x to the 4th minus 7x squared plus 12 equals 0. So when you see this, you're like, x to the 4th, man, I haven't really worked with that very much. So the first thing you always want to look for is see if there's somehow a GCF. Okay? In this problem, there isn't a greatest common factor. So you're looking at it going, what do I do next if I have an x to the 4th? Well, this is a unique problem, and we're going to do what we call a u substitution, okay? But before we do, I'm going to rewrite this a little bit differently, okay? Notice that the middle term is x squared. So I'm going to rewrite the first term as an x squared. And it's really x squared squared. X squared raised to the second power is equivalent to x to the fourth. Minus 7, I'm going to put the x squared in parentheses, just so you can see, plus 12 equals 0. Notice that what I have in parentheses is the same, okay? That is going to be my u substitution. So over here I'm going to write let u equal x squared. Okay, so I'm going to take that x squared out and I'm going to put u in its place. Alright, when I do that, again, I'm going to take those x squareds out, so let me show you. So there's nothing in those spots. I'm going to go ahead and wherever those x squareds were, I'm going to put a u. I'm going to put that in a different color for you. So we're going to make this a u and this a u. Now I'm going to write it without the parentheses. We have u squared minus 7u plus 12 is equal to 0. When you look at something like that and you're trying to solve it, hopefully you look at it and you say, oh, that's a quadratic. And you can either factor or use a quadratic formula. I always try to factor when I can. So take a minute, pause if you need to, and factor u squared minus 7u plus 12. Alright, this factors to u minus 4 and u minus 3. Okay? Now, continuing the way we've been solving quadratic equations, once I have my factors and they're equal to 0, I can use my zero product property and set each factor equal to 0. That leaves me with u equal to 4 over here and u equal to 3 over here. But remember, let me change colors for you, that I had u was really equal to x squared. I have to go ahead and use that and substitute it back in over here. So instead of u equals 4, I'm going to replace that with the x squared. I'm going to put it back because that's what it originally was. So x squared equals 4. Same thing over here. The u was really equal to x squared, so x squared is equal to 3. Now I'm solving this. Okay? If you remember, we did the square root property. So I take the square root of both sides. Remember, when I'm taking the square root of a constant, I'm going to do the positive and the negative. So that leaves me with x equals the positive and negative square root of 4. So the square root of 4 is 2. Over here, I'm going to do the same thing. I'm going to take the square root of both sides. I'm going to remember to do the positive and the negative. So that leaves me with x equals, in this case, square root of 3 doesn't come out nice, so we're just going to leave it as the positive and negative root 3. So I actually have 4 solutions. My solutions are positive 2, negative 2, positive square root of 3, and negative square root of 3. Those are my solutions to this equation. Example 8. Solve the quantity 7z plus 5 squared plus 2 times the quantity 7z plus 5 minus 15 equals 0. Again, looks like another funky problem. Notice we have 7z plus 5 here, and we have 7z plus 5 here. This is very similar to our substitution problem that we did in example 7. When you have the same thing, you can make your life easy by doing a u substitution. Now, could you FOIL this out and distribute and solve it? Yes, it's just going to be a little bit longer. So let's let u equal 7z plus 5. That's going to be my u substitution. So I'm going to take those out and put u's in their place. So that leaves me with u squared plus 2u minus 15 is equal to 0. Now I have this nice quadratic equation, and again my options are to factor or use the quadratic formula. I always want to factor if I can. So what are factors of u squared plus 2u minus 15? Again, pause if you need to give yourself some time to factor it. But those factors are u plus 5 and u minus 3. Zero product property says go ahead and take those factors and set them equal to 0. One of them must be equal to 0. So u plus 5 is 0, or u minus 3 equals 0. That gives me u is equal to negative 5, or u is equal to positive 3. Alright, just like we did before, we had this u substitution, so I have to go back. I don't want to know what u equals, I want to know what z equals. So I'm going to take that u out, I'm going to put the 7z plus 5 back in for u. Over here, I'm going to put the 7z plus 5 back in for the u, and I'm going to solve those two equations. So this first equation, I'm going to subtract 5 from both sides, so that gives me 7z equals negative 10. I'm going to divide both sides by 7, which gives me z equals negative 10 sevenths. My second equation, I'm going to subtract 5 from both sides again, so that gives me 7z is equal to negative 2. Divide both sides by 7 again, I'm going to get z equals negative 2 sevenths. So I have two solutions, negative 10 sevenths and negative 2 sevenths. Example 9, we're going to solve this equation. As you can see, we have this x squared minus 6x here and another x squared minus 6x. Okay, this is very complicated as is. So whenever you see something super complicated, you're probably going to want to do a u substitution to simplify it. So I'm going to say let u equal x squared minus 6x, since I have that in both places. That simplifies. Now I have just simply u squared plus, and I'm going to put a 1 here just so I know, plus 1u minus 56 is equal to 0. Now I have a simple quadratic equation that I can take and factor. Okay, so take a minute. Again, if you need to pause, please do. I'll give you a minute and then I'll write the factors up. Alright, our factors are u plus 8 and u minus 7. Zero product property tells us we can take each of those factors and set them equal to 0. So u plus 8 could equal 0, or u minus 7 could equal 0. Solve each of those. So u equals negative 8, or u equals a positive 7. Now we know in this problem we're not trying to solve for u. So we need to go back. We knew we made a u substitution, so this is really going to be x squared. Oh, let me get my pen. My apologies. Here we go. This is really going to be x squared minus 6x is equal to negative 8. And over here we're going to have x squared minus 6x is equal to 7. And I need to solve both of those. So the first one, the x squared minus 6x equals negative 8, I'm going to move the 8 to the left-hand side to get it in a nice form for us. That gives me x squared minus 6x plus 8 equals 0. Go ahead and factor that. My factors are going to be x minus 4 and x minus 2. Set those both equal to 0, and I get the solutions x equals 4 and x equals 2. Alright, I'm going to do the same with my other equation. I'm going to go ahead and move that 7 over. That leaves me with x squared minus 6x minus 7 equals 0. Factor that one as well, x minus 7 and x plus 1. set each of those factors equal to 0, and I get x equals 7 and x equals -1. So I actually have 4 solutions to this equation. My solutions are 4, 2, 7, and -1.